Hi everyone. In this video, I'm going to show you how to figure out the stereochemistry for sugars. Okay, so the first stereochemistry assignment we're going to be doing is on the atoms of the sugar, whether what stereochemistry they have, and we'll get to the classification, the Dnl, later, right after this. So for the stereochemistry of each atom, there's a trick, the trick you use. So these are, by atoms, I mean all these carbons, right? So as you guys could tell, all four of these carbons on this particular sugars, they're all chiral. Okay, so how do you go about assigning the stereochemistry? So the first thing you have to do is you have to convert the Fisher projections to this convention where you have the right and left wedge and then up and down dash. Okay, so you could only do one carbon at a time, so let's focus on this carbon right here. Okay, all right, so let's draw that out in that configuration. So here you have the carbon, okay? And I'll just draw the carbon right here, okay? And on the sides, you have, on the left, you have H. On the right, you have OH. Going up is you have your aldehyde, CHO. And going down, you ultimately have a carbon with other substituents. So I'll just label that, carbon, okay? But that carbon has OH and H, okay? So after you draw it like that, now you need to do is label the priority, right? So this is what you've done back in Chem 8A, right? It might have been a while, so let's go and assign the priorities of the substituents, right? So with respect to this carbon right here in the middle, okay? So the number one priority is, so the way I do it is I go each atom out in all direction, okay? So if I go to the right, I have this oxygen. If I go up, I have carbon. If I go to the down, I have carbon, right? So obviously oxygen has more priority because it's a heavier atom, right? So that you label 1, okay? Now you're between up and down, right? So if you go up, you have a carbon. If you go down, you also have a carbon. So how do you decide which carbon to pick? How do you decide which carbon to pick? All right, because at the top you have an aldehyde, if it helps, right? Draw out the aldehyde. The top carbon you have bonded to oxygen, but bottom carbon is also bonded to oxygen. However, the top carbon has 2 bonds to oxygen, so we double count it, right? So the second priority will go to your top carbon, okay? And then that will make your bottom carbon number 3, and obviously your hydrogen will be number 4. So which direction is that going in? So if you trace it, it's going in this direction, right? Which is counterclockwise, right? You know that counterclockwise is S, okay? So, okay, it's S, so you came to the conclusion. But then you take a look at it, you see that your lowest priority substitution, which is in hydrogen, right? It's on a wedge. Because the lowest priority substituent is on a wedge, you switch up whatever you got, right? So you found out it was an S, but you cancel that out because the hydrogen is on wedge. So you make it into an R, okay? Good, that means the first carbon is R, okay? Now how about the second carbon, okay? So we could do it now without having to draw, just by using the trick, right? So let's look at the second carbon without drawing what I drew. So the second carbon, right, your first priority substitution is going to the left, which is the hydroxyl, that should be 1, right? And then you have top and bottom, you have both carbon with an OH on it, so you can't really decide which one is 2, right? But then you go one more carbon out, right? If you go one more carbon out, you got this carbon on top. If you go one carbon out at the bottom, you got that carbon on top, right? So the top carbon wins out because, again, it's an aldehyde with 2 C double bonded to an O, so we count it twice. So the top will be your 2, it means the bottom carbon will be your 3, and H is 4, okay? So here, which direction are you going in? Here, if you follow 1, 2, 3, you're going clockwise, which is R, okay? But remember, right? Remember, again, if you were to draw this carbon in that configuration here, H, would have been on a wedge. Because the H would have been on a wedge, you switch your configuration, so it goes to an S, okay? So you guys could try the next two carbon on your own, and if you have any question, we'll go over it in my office hour. So next we move on to Dnl assignments, okay? And it's really important to remember the Dnl assignment is only based on the penultimate carbon, okay? So what does it mean by penultimate carbon? The penultimate carbon is the carbon that is one carbon up from the last carbon. So what do I mean by that? So let's look at the D-glyceraldehyde, right? So the D-glyceraldehyde right here, right? The last carbon is this one right here, right? So its penultimate carbon would be this one right here, okay? So the Dnl assignment would be based on that configuration of that carbon, okay? And remember, right, there's a trick to remembering. So the way I do it is, if it's to the right, if it's going to the right, okay, it's D, all right? And if it's going to the left, then it's an L, okay? Right D, left L, okay? Remember that, right D, left L. So you can see the reason why D-glyceraldehyde is D is because on this carbon, the OH is on the right, okay? Same with this. So the penultimate carbon of glucose is this one right here. And on that carbon, the OH is also to the right, okay? So that means it's D. And you could use the D-glyceraldehyde. You should memorize just D-glyceraldehyde, and then you could label everything based on that, okay? Same with D-fructose, right? This is the penultimate carbon, right? It's going to the right, so it's D. Okay, so let's look at the stereochemistry review. Okay, so you're given the D-glucose below, and how do you make the L-glucose, right? Again, so the D-glucose is D because of the penultimate carbon, which is this carbon right here, where the OH substituent is going to the right. Okay, so in order to draw the L-glucose, you just flip the configuration of that particular carbon, right? But everything else stays the same, nothing changes. So you draw your skeleton. The way I like to do it is draw lines, okay? So nothing happens to this carbon, nothing happens to that carbon, nothing happens to this carbon. This is the penultimate carbon right here. And what do we do to that? We switch the configuration. Before, when it was going to the right, it was D, so I make the OH go to the left to make it an L. So there you have it, okay? Same with the L-aldose, okay? L-aldose. All right, this is again the penultimate carbon. That's what's giving it the D configuration, right? So if I want to draw the L configuration, all I have to do is draw that penultimate carbon, but with an opposite configuration. All right. Okay. And I'll see you guys on the next video.